Good morning, students. Magnetic effect of currents. Okay, we will continue our topic here. See first question. It is a thin circular disc of radius capital R is uniformly charged with density sigma per unit area. The disc rotates about its axis with uniform angular speed omega. We have to find what is magnetic moment of disc. See, to find magnetic moment of disc, what is equation? Actually, equation of magnetic moment, M is equal to a disc, Nia. Or if you are given number one term, one, so you can say it is Ia, where I is current. Yes, you can easily find area. The area is equal to this pi r square. But what about I, current? Okay, you are given a thin circular disc of radius r, which is uniformly charged with density, uniform charge distribution on that disc. So first of all, you have to find what is equation of current. Okay, what is current flowing in this disc? But it is difficult. Okay, yes, it is given whole disc uniformly charged, and how to find current. So see, how to solve this question? I am taking to suppose it is this. Okay, it is disc of radius r. Okay, it is rotating with angular speed omega. I am assuming, or I am taking one element of this disc like this. One element of this disc at distance x having thickness dx. Okay, first of all, I will find magnetic moment of this ring only. Yes, this element is ring only. Okay, so they take a ring as element as shown in figure. So first of all, how to find? So yes, first of all, I will find okay, what is charge on this ring. So charge on ring. Charge on ring. That is dq is equal to, we have equation, it is sigma dA. Yes, you have equation. Okay, what is charge on element, that is charge on ring, dq is equal to sigma dA is equal to sigma. What is area of this ring? Yes, area of this ring, we know that it is 2 pi x dx. Yes, it is 2 pi x dx. So take a ring as element as shown in figure. First of all, find charge on ring, that is dq is equal to sigma dA, sigma 2 pi x dx. Now, as this disc is rotating, we can say this ring is rotating, and as this ring is rotating, charge on it is also rotating, and due to this rotating charge, current is produced. So yes, current produced due to ring, that is di is equal to dq upon t. Yes, I have told you. Okay, for circular motion, which equation of current you have to use? Charge upon periodic time. Okay, so di is equal to dq upon t, or you know what is relation between t and omega. Yes, we know equation, that is omega is equal to it is 2 pi upon t. So t is equal to it is 2 pi upon omega. So I can replace this t by 2 pi upon omega. So is equal to, put value of dq first of all, that is sigma 2 pi x dx. Now put value of t, that is t is equal to 2 pi upon omega. So it is 2 pi upon omega. So 2 pi third, 2 pi third. So therefore, what is value of di? Di is equal to, di is equal to omega in numerator. So you can write this sigma omega x dx. So yes, it is current produced due to this rotation of ring. So I will find magnetic moment of ring. Magnetic moment of ring. So what is magnetic moment of ring? Dm is equal to, yes, it is di into a. So is equal to di into a. Di, current flowing in this ring, it is sigma w x dx. What is area enclosed by this ring? That is pi x square. that is pi x square. So yes, you can write it is sigma omega pi x cube dx. Yes, it is x cube dx. Now take a ring, find charge on it, find current due to it, find magnetic moment of ring, but we have to find for this. So for this, I will write for this. What is moment of magnetic moment of this? Magnetic moment of this, that is m is equal to integration dm is equal to integration dm with sigma omega pi x cube dx. Integration, yes, x, integration is with respect to x, and what is x? The distance of element from center, and yes, you know that limit is from 0 to r. Yes, what is limit? Limit is from 0 to r. Yes, limit is from 0 to r. Is it visible? Yes, it is visible. Okay, so yes, limit is from 0 to r. Now integrate this. Sigma constant, omega constant, pi constant. So I can write sigma omega pi constant. What is integration of x cube? It is x4 by 4. Limit is from 0 to 4. So is equal to sigma omega pi. Here it is r square by 4 minus 0. So is equal to sigma omega pi r square by sigma omega pi r square by 4. Simple. Okay. So see how to solve such questions, as it is you are given this. What is equation of magnetic moment? That is I into A. You know A, but how to find current? You cannot find current directly because it is uniformly distributed. So you have to take one element. Take one element, that is ring. Find charge on it. dq is equal to sigma dA. Find current produced due to ring. That is dA is equal to dq upon t. T you can write 2 pi upon omega. So it is vi. Magnetic moment of ring is equation. That is current into area enclosed. So it is this one. Now for this magnetic moment, you have to integrate from 0 to r, because its radius is from 0 to, here it is r. Clear? So yes, it is one question which is based on magnetic moment of current. Next question. You are given one figure. Okay, there are two wires of length L like this. Two wires of length L like this. Okay, yes, these are two wires carrying current in same direction. That is II. Their length is LL. They are suspended by strings of equal length, that is capital L, and in equilibrium the substance angle theta is vertical. So your question is, if wires have, okay, next question. See what is next question. I will read data from book. That is, two long current carrying thin wires, both with current I, are held by insulating threads of length capital L and are in equilibrium as shown in figure, with threads making an angle theta with the vertical. If wires have mass lambda per unit length, then find what is value of I. See what is question. These are two wires having same length, small l. Okay, current, that is I and I. They are suspended by threads of equal length, that is L. In equilibrium, it makes angle theta with vertical. Okay, then you have to find it in equilibrium. Question of current I is equal to what? You are given wires have mass lambda per unit length. Mass lambda per unit length. Now see, as you are given one hint, okay, it is an equilibrium. In equilibrium, what is condition for equilibrium? So yes, we know that for equilibrium, sigma f is equal to 0. For equilibrium, sigma f is equal to 0. Now sigma f is equal to 0 means in horizontal plane, sigma f is equal to 0, and in vertical plane sigma f is equal to 0. In horizontal plane sigma f is equal to 0, and in vertical plane sigma f is equal to 0. So first of all, you have to identify numbers of forces acting on this system. First, as these wires have mass lambda per unit length, they have some mass, and due to their mass, first force mg, that is acting in vertically downward direction. First force. As this wire is suspended by a thread, yes, tension is produced in between, that is T in this direction. Now see, this mg is in vertical plane, but this T is not in vertical plane, so we have to resolve this T into components. One vertical component, one horizontal component. There is angle theta, so this angle will be theta, so here it is T cos theta, and it will be T sin theta. Now, one more force. It is current carrying wire, it is also current carrying wire. There are two current carrying wire in parallel, they are parallel. So yes, on these two wire there is also some force. You know in theory, okay, between two parallel wires carrying current there is some force. And what is equation of that force? For which type of force? So obviously repulsive force, because the system is in equilibrium. So force acting on this wire due to this wire, it will be obviously in this direction. That is Fm. That is Fm. Force between two wires. Force between two wires. Okay. So for horizontal, sigma f is equal to 0. So I can write T sin theta is equal to Fm. And for vertical plane, I can write T cos theta is equal to mg. Now what about this Fm and mg? See here. Fm is equal to force between two parallel wires. Between two parallel wires. We know its equation. Fn is equal to mu 0 I1 I2. What is length of this wire? L upon 2 pi d, where d is distance between two wires. Now how to find distance between two wires? See, here it is. Take this triangle. In this triangle, if you take sin theta, that is sin theta is equal to opposite side with this one. Opposite side with this one. Okay, this side. So let it is d by 2. Hello, let it is d by 2. Obviously, if this distance is d, then this distance is d by 2. Then sin theta is equal to it is d by 2. Opposite side upon hypotenuse, that is L. Okay, so 2L sin theta is equal to it is 3. So put here your value. The Fm is equal to mu 0 I square L upon 2 pi. What is d? It is 2L sin theta. So therefore, Fm is equal to, it is mu 0 I square small l upon 4 pi L sin. So it is Fm. Now what about mg? M, that is mass of this wire, but you are not given mass of this wire. So how to find it? See, mg is equal to m, that is mass of this wire. And for wire you are given, okay, wires have mass lambda per unit length. What is length of this wire? That is L. So what is mass? It is lambda L. It is lambda L G. Yes, you know what is mass. It is lambda. Lambda is equal to m upon L. So m is equal to lambda into L into G. Now in this equation here, if you take the ratio, that is T sin theta upon T cos theta is equal to, it is Fm upon mg. So you can write T cut. So it is tan theta is equal to, or what or? You can put value directly here. Okay, here it is sin theta upon cos theta. So what is value of Fm? Fm is here. It is mu 0 I square L upon 4 pi L sin theta. 4 pi L sin theta divided by mg. Lambda Lg divided by mg means it is lambda Lg. So this L cut, L cut. Okay, anything else? No. Okay, so make I square as subject, then I square is equal to, I square is equal to, yes, what is value of I square? So yes, how to find value of I square? I square is equal to, you have to write this whole term here, okay? So it is 4 pi L lambda G sine square theta. Sine square theta. Okay? Okay? Divided by mu 0 cos theta. And yes, if you want to find I, then I is equal to this under root 4 pi L lambda G sine square theta upon mu 0 cos theta. And yes, it is your answer. Yes, it is your answer. Clear? So there are two questions. Yes, I think these two concepts are enough to understand some concepts of today. Okay? So yes, for today this is it. These two questions only. Next question we will see in next lecture. Okay? Next questions we will see in next lecture.